depended on the electricity. So it is good to know the history of that electricity. So we are now living in the 2023, but the journey of this electricity actually started from BC. So nobody can expect that. So it started from the BC, and in fact, it is in the nature itself. In the olden days, the people know what is the shock, electric shock. You don't know. You may get wondered how they know. So it is because of the fish, that is eel fish now, but they were calling it as the thunder of the Nile. And also the people know about the thunderbolt. So that's why they call that fish as the thunder of the Nile. Even some doctors suggested the people who are suffering with some headache and different health problems to get it, try to have a small amount of shock. That's how they tried to use it medically. Okay. So if you 1938, the excavators in Baghdad, Iraq. Iraq is the capital of Baghdad is the capital of Iraq. So in their excavation, they found a thing which is similar to the galvanic cell, and they called it as Baghdad battery, and the carbon dating is went to 250 BC. So that means there is some evidence that the olden people know about this electricity. Now, maybe now, yes, now we are using it at our highest, but in future also we need more and more power. That's why we are going for different alternatives of the power sources. Okay, anyway, that not yet proved, but we can claim some proof, not totally. But so in ancient, so if you come to the electricity, the two types, either it started from the battery and it started from the magnetic field, it started from the charge. Okay, so the ancient Greeks. So if you want to tell about the electricity, so we have to start from the electron. That means you should know what is the atom, what is the molecule, what is the mass. Okay, so what are the particles? So now afterwards you should know what is positively charged and what is the negatively charged things. But olden the Greek people might not know about the electron, but they know that there are some particles when you rub. Okay, when amber. So if amber is rubbed with wool, so what happens? The amber becomes negatively charged and the wool becomes positive charged, and the amber attracts some feather. So that means you have that knowledge, but you don't know what it is. You don't know what it is actually. So Greeks, the early stages, they know. So that means by rubbing, some exchange is happening and some attraction is happening. And ancient cultures around the Mediterranean knew that certain objects such as rods are rubbed with cats for attract light objects, not only feather. Some light objects they will attract, and so at the same time, the Greek philosophers uh, has found that atoms, so atomic theory, which is more similar to our modern atomic theory, they were able to estimate that yes, the matter is made up of some molecules or some atoms. Atoms means which is not further dividable in Greek. The word atom means which is not further dividable. That's the meaning in Greek. Okay, so that is actually the foundation for. So first they were able to estimate that there will be some material which is the foundation of all the matter which we are able to see. At one stage, that the Greek philosophers they told that except atoms, everything is not reality. So to that level, they were thinking about the atoms. So the Thales of Miltiades, a Greek philosopher, observations on static electricity. So this also 600 BC. Static electricity. See how much earlier they were able to have detect about this electricity. So he found that without rubbing, he suggested some materials without rubbing, like magnetite. They are showing some properties of attraction. So afterwards, the scientists, after 2200 years, they were able to find that mystery. So next, William Gilbert in 1600. Now we have shifted from BC to AD. Okay. Physics. He is a physician. He belongs to London. So he has done some research on magnetic phenomena, and he found that the Earth itself is a magnet. Earth itself is a magnet. So now we are enjoying the results of this electrical and electronics. It happened for centuries. The evolution happened for centuries. So prior to 1800, the scientist who has contributed to the electrical engineering are William Gilbert and Coulomb, Galvani and Benjamin Franklin, Alessandro Volta. Okay. So this is in Michael Faraday. Okay. In between 1821 to 1831, he has worked on induction. Okay, induction principle. At the same time, parallelly, some other scientists, Joseph Henry, was doing the same research on the same thing. Okay. Afterwards, from 1840 to 1870, Charles Whitson, Alfred Warley, and the Siemens built primitive generators starting. So 1842, they were able to build primitive generators based on this induction principle. So which was proposed by this Faraday and also parallelly by Henry. Okay. So the commercial afterwards generator was one part, and lightning arc. So they found whenever the electrodes were separated, we can find an arc. We can find an arc. So that the commercialization that was happening in 1870s, the arc lamps were used in lighthouses and streets, and after that lamp, then they went for incandescent bulb. So nowadays you may not be knowing about the incandescent bulbs, but before 10 to 15 years, before tube lights, they were the main sources of lighting in our homes. So that means whenever it is heated, we can produce the light. So that's why it is called as the incandescent. So in vacuum. So the Thomas Alva Edison. Yes, this Edison is famous for everyone. He has done experiments for so many times, and finally he was able to do it with the help of the carbonized cotton thread filament in a vacuum enclosed space. This was the first electric bulb, and it was able to survive before burning out for 44 hours. 44 hours constantly. Afterwards, he has improved that version. So, after that invention, he was able to commercialize that incandescent bulb, and in New York City, Parallel Street Power Station in New York City was established in 1882 to sell electric energy for incandescent light. So these bulbs were famous, so everybody wants to have it, and for that supplying purpose, the power station was established in 1882 in the New York. Okay. So what the problem is that you will use the lights only during the night, which is and what we have to do in the daytime. So for that, they were free. So something should be done such that the people will use the electricity even during the daytime. So for that purpose, afterwards they were able to come with motors. Okay, initially bulbs, the two incandescent bulbs were very, very famous. So generators anyway, that starting itself, Alfred Wheatstone, so 1840 to 1870, anyway, they were able to find primitive generators. So incandescent were famous by the time 1882, and but what to do the power in the daytime? So nobody using, no need, because there is no instrument which you can use with the electricity during the daytime. Only in the night time the bulb is needed for the people. So they came. Finally, they developed how to do. So the people should use the electricity even in the daytime and even in the night time. So they developed the motors quickly. So how the motor? Actually, first they were able to develop the generator. So accidentally they have done some reverse thing, and they found that it is working. So it is able to generate the mechanical energy. So inspired by the William Gilbert, European inventors such as Otto from Germany, he is from Germany, Charles of France, Stephen Henry of England, they expanded the knowledge of electricity, and they have worked on that also. So again, statical in 1660, Otto was able to find the first electric generator. In 1720, Stephen Gray discovered the principle of conduction of electricity. Okay. The Charles Francois discovered that electricity comes with two forms. So there are two types for a battery, that is resinous, which is negative charge, and vitreous, which is positive. So he found that there are positive and negatives are there. So Benjamin Franklin, he was the man who was able to find and convince the people that the thunderbolt is, which was a mystery. Okay, and it is nothing but the electricity, or it is the charge which flows. So with the he conducted a famous experiment that is called as kite and key experiment. So with that experiment, um, he used to select the place where frequently the thunders will occur, and there he called the famous scientists or people, and he showed whenever that thunder is happening, the lightning is happening in with the help of key. The charge, some charge is coming, or afterwards he was able to show some lightning in the vacuum in a bottle, like that. So he was able to convince that. And Galvani, so Italian professor, so famous frog leg. So this Galvani, what he taught that, so electricity is something which related to the life. So why he thought like that is that whenever he touched the experiment, okay, famous experiment using frog leg. So he thought electricity was one of the source of life. Some ideas that related to life at that time. So whenever he he touched the leg of a dead frog by a metal knife, the leg twitched violently. So he thought that a muzzle of the frog must contain electricity. So this thing, this thing gave an idea that maybe the electricity is related to some bio products. That means it gave weight for the bioelectricity. It gave a way for thinking about the bioelectricity. So afterwards, they started research on that, and even now they found that. So even our neurons in the brain, actually, they communicate with the help of the electrical signals. Okay. So this thought was because of this Galvani. But Volta, so Volta, he disagreed with this. Person, and he is a person belongs to the Italy, and at the age of so he's Volta, and he has proved that it is not because of that frog leg. It is because of the instrument he is using. It is due to the different reason, that is because of the metals he is using. So he showed that the moisture comes between two different metals. Electricity is created. So by this experiment, by this thought, he was able to develop, with the help of the copper and zinc, he was able to finally produce the battery, DC battery. So always DC is the always battery is the DC thing. Okay, and generator will naturally produce the AC thing. Okay, that's the clarity before that subject you have to know. So Oersted, so he is a person observed about the magnetism, whether there is any link between the magnetism and the electricity. So he has found that there is some link, and this later and Coulomb also electrical charge. Electrical charge is well for he was able to produce a mathematical reason for this, and Gauss method. So he also explained about the link between electricity and magnetism, and Ampere. So he also discovered the mathematical Ampere. He was a person, a mathematician actually. So magnetism and motion, there is some link between magnetism and motion of the electrons, and so he is a French lawyer, town of the French lawyer. He discovered the famous law, that is the Ampere's law. Next, George Simon Ohm. Um, this is the person he found that. So earlier, everybody knows that electrons are moving in a conductor, but why there is some force is needed to move it. So he is a person who found that there is some resistance. So to overcome that resistance, we need the external source. So that's why he was able to find why the voltage or potential is needed to move the electrons. So on his name only. So on the name of the ampere, the current units, and on the name of this George Simon Ohm, the ohms, the units of the ohms. And Humphrey David, British chemist, he started on the electrochemistry. Okay, so this is also the thing which later developed. We are able to develop which is helped in the batteries nowadays we are using. Faraday. So Michael Faraday. So with this fellow, a different story starts about the electricity. So he was able to understand about the concept of the magnetism and electricity, the link between this magnetism and electricity, which later led to the development of the generator. Okay, electromagnetic induction. So next thing is Grammy. So again, Faraday is able to produce the power. So this Grammy in 1869, he improved the AC generator, making more practical device for the production of alternating currents. Next, again, 2 years later, he improved the DC dynamo. So this is how the evolution has. So this person is the accidentally. So Grammy one day accidentally he was able to find about the electric motor. Okay, so first Faraday developed the principle for the Michael Faraday, for which is generator, but Grammy developed this AC generator and also DC dynamo, and also accidentally found the electric motor. Okay. So Tesla is the person. Before this person, everybody was using about the DC power, and he is the person who told that utilization of using AC is more easier and economical than the DC. Okay, so Tesla, first he was working with Edison, and he convinced about the advantages of the AC. So the alternators did not need the slip rings and commutator. So actually the AC, the generator actually produced the AC power. So those days we were using the DC. So for that we need this commutator which converts AC into DC. Again we will take the DC supply. So that is not needed if you are able to directly use the AC naturally, which is coming with the which is produced in the generator. So except if you are able to do the battery. So battery naturally comes by the um, DC current. And except that, if you see, if you are using the generator, so either you may go with thermal power, which may be coal, which may be um, oil, which may be gas, okay, which may be the nuclear power. So ultimately, the turbine has to be rotated and which is linked with the generator. So it naturally produces the AC current, alternate current. But even if you go for the hydropower, here also you need to rotate. So wherever there is rotation is involved, so there is the generation of the alternating current. Even if you go to the wind power, so there is rotation. Even if you go to the solar thermal power, there is rotation involved, turbine involved. So wherever there is turbine involved means you are producing the AC is produced naturally. Only if you provide that commutator, you can convert into DC. Except this photovoltaic cells. So these are the things which will naturally produce the DC power. So this Tesla was able to convince. So another thing is why this man um, encouraged this AC power. Why this man wanted to encourage this AC power is that we can transmit it to the more distant places with the help of the transformer. Okay, and also for this he invented the induction motor. Okay, so in 1888 he got the patent for his electric motor, and later he sold that patent. So in 1895, the water power of Niagara Falls was begun used to generate alternating current. So the first AC power generation happened in the Niagara waterfalls, with the help of the Niagara waterfalls, and afterwards everywhere we started producing directly AC. So next, the 19th century. Actually, the 19th century is the place where uh, more progress happened. More progress happened in the field of electricity, and in the next century, the more progress happened in the field of electronics field. So, 19th century electricity progress, and 20th century electronics progress. So electronics actually started with basic things, that is vacuum tube, transistor, and integrated circuit. So Marconi, so radio. So he needed a good rectifier which can convert AC to DC. So for that radio, slowly again the development of the rectifier happened, and also vacuum tube, which is known as Edison effect, and John Ambers Fleming. He's an English electrical engineer, invented a thermonic valve or vacuum tube. So it happened in 1904, and he is also famous for his left hand. Okay, and Lee de Forest. Just after 2 years of Fleming's diode, so the vacuum tube diode. So they were able to produce the similar thing, which is having the three electrodes. Okay, that is called as a triode. Diode means di means two, and triode is three. Tri means three. So uh, this is the evolution process of electricity, which started from the natural things, and which started from the rubbing, which started from the charge, idea of the charge, which started from the idea of the atoms, which started from the idea of the magnetism. Okay, slowly they are developing. They developed. So it started from thunderbolt, so which this person was able to convince it is not some magic; it is just the charge flowing. Okay, so afterwards, so many scientists developed these batteries, generators, motors. So this development of the electricity slowly led to the development of electronics, and electronics slowly led to the birth of the software industry now. Okay, so this is the actually process, which was the actual process which happened. So this is the introduction which is needed to know about the basic electrical engineering. And in the upcoming videos, we will slowly go into the what is basic electrical engineering, what is the current, what is the voltage, okay, and what is the resistance. All these things we will discuss in detail. Thank you for listening. Thank you for today.
Like, share and subscribe. Hit the bell icon for more updates.